Hello everyone and welcome back. This is video 32. In the last video, I basically finished up this disk space metric. So I added this from future import division, which lets you use the Python 3 style division in Python 2. It just means that when you take two integers and you divide them together, the result is a float. So without this, in Python 2, two integers divided by each other returns an integer, and that's not really useful for us. So I added this here just so that it's using division correctly in both Python 2 and Python 3. And so down here, this internal name from args, I removed it because this is on the directory size metric. I removed this because a couple videos ago I moved this internal name from args onto the base class. And so what this is doing is more or less the same thing as the base class, what it does, except the base class does it kind of in a more generic manner. So here I just removed it. And so now this mini hash thing is being calculated on the base class. And so here I removed a line, removed the empty line, and then before I had planned on doing disk space free, disk space percentage free, and disk space used. Three different metric classes, but I decided I'm not going to do it that way. I'm instead just going to have one class called disk space, and then there would be a dimension argument, and the dimension argument will either be free, used, or percentage free, or percentage used. And you can see here it's kind of works like this: dimension free, dimension used, dimension percentage used. And then you pass in the device, which is the device that you want to calculate for. This is disk 1S1, which is like my main laptop's hard drive. And then it's using the same class. And that's just how I decided to do it. And I included the this underscore bytes, which I wrote a couple videos ago, that automatically converts byte values to like gigabytes or megabytes just so it looks better on the graph. It kind of automatically scales it. And then make title, again, is just taking this dimension and setting the title based on if it's used or if it's free, based on what the dimension is. And then traces, there's one trace for each device, so we just loop through each device and we make a trace object with the name set to the device. And then here we save the devices and the dimension. And then we set the Y title to percent if the dimension ends in percent, or if it starts with percentage. So that's what sets this right here. So this one's percent, used percent. And then this one is used for gigabyte. This is the underscore bytes thing where it converts it to gigabytes instead of just bytes. And then in the parse df, which I wrote this, not last video, but the one before that, there was one small bug in Python 3 where it would give an error on this line. And it's because in Python 2, filter returns a list, but in Python 3, filter returns a generator. And you can't take the length of a generator. So in Python 3, this would crash, and so the fix would be just to wrap it in list. In that way, you can take the length of it, and it'll work. And it's okay. Like normally, you wouldn't want to do that to a generator because you want the generator to remain a generator for performance reasons. But in this case, this line dot split, it's only going to return like 10 items or maybe 20 items maybe. Like it's not going to return a huge number of items. So it's okay to turn it into a list. Now if this returned like a billion items, then it would be a problem. But it's only returning like 20 or something. So it's not a big deal. It's not going to affect performance. And then down here, this is the poll method. This is actually, so first we get the df from parse df, and then we loop through each device. And depending on which dimension, we will pull that dimension from the parsed df and then store that into results. And so results is going to be a dictionary where the key will be the device and the value will be the actual free space or used space in bytes. And then that gets returned. And then also if the dimension is percentage, then we do the same thing except we divide by all, and all is just free plus used, and multiply by 100. And then if it's used, it'll be used divided by all times 100. And then that gets returned down here. And then, of course, result to matrix turns that. This implementation is exactly the same as it was on the directory size metric, except it's devices instead of directories. Everything else is the same. It just converts the result that gets returned up here, and it turns it into a column for the matrix. And the matrix is used by the charting, the front end. It turns that into an actual chart. So that was what I did in the last video. And in this video, I'm going to just make I'm just going to make probably two more metrics. The first one would be called memory. And the other one will be CPU. And the way I'm going to do this is this library called psutil, which is what I used in the uptime metric. Yeah, psutil, where is it, .boot time, to get when the system was last booted. And so I'm going to use that for getting the free memory. So first I'm just going to make a poll method. And this is memory. So I'm going to scroll down and find the memory. Here it is. So it's called psutil.virtualMemory. I'm just going to do that. And first I'm going to init initialization. And it's going to be mostly the same, so I'm just going to copy it all. Except we don't have devices, so I'm going to remove that. But there is dimension, so we want free, used, percent free, and all that stuff. So I'm going to keep all that. And then go to the shell and test it. This is what gets returned. So this is a this svmem. It's a named tuple. I know that from reading the documentation. So here's all the various attributes and metrics that exist. So what we're going to use is percent, which is already here, used, and free. These are the ones we want. So it's based on the dimension. So just call this mem. And say x equals that. So x dot free, and it just returns it like that. So the way this is done, so we don't have, all we have is a string, so the way we do that is get adder, and then we just say that as a string, and it's the same thing as dot free. So we're going to say dimension like that. There it is. And then we can say There it is. And then if we go percent used, it's going to probably crash. Yeah, because there's no percent used. It's instead called something else. I think it's just called percent. So we'll say if this is assuming that percent is giving me percent used. I'm not sure if it's percent used or if it's percent free, but we'll find out. So now we'll test it. Oh, it's percentage. There it is. Percent used 71. Then it looks about right. So now we will add the title. And this has to be get title. It's going to be exactly like the previous one. Yeah, except memory instead of disk space. And this also percentage is going to be here also. And then the next thing is traces. It's going to be the same, except it's actually not going to be, because there's always going to be just one trace. So I can just leave it, because by default there's one trace. So by default, one trace. So I'm just going to leave it. And that looks like that's it. So now I'll install it and see if it works. So I did all of them. Now we will make a tick. There we go. Looks about right. Now we'll go to the page and refresh, and it should show up. Gotta restart the server. Okay, there's only one point, so I have to make a second tick to make it a line. There we go. It's kind of taking a while. It's starting to get slow. Memory used, it went up. Memory used percentage. This one is, it's not showing the, it's not showing this here. Here, the percentage is being shown properly. And then free, it showed it going down, and then free percentage is showing it down. So that way we know that this is correct. I kind of guessed which one it should be, if percent was used or if percent was free, but I guessed correctly because it looks like it's showing it properly. So next thing I'm going to do is open up the dev console and refresh. And it was kind of slow, so you can see this matrix call is taking 2.48 seconds, which is a long time considering that there isn't a whole lot of data here. So the reason for that is this this make matrix is taking a long time, so I'm just going to do this, go t0 equals, so I'm going to get the current time at the start of the function, and then at the bottom here, print out how long it took. So the current time at the bottom minus the time at the top, and then we'll print it out, and that'll tell me how long it took to generate this function. And so I'll now refresh, and it'll get printed out on here it is. Matrix took 2 seconds, 2.9 seconds. So that's really slow. So when I wrote this, I wasn't trying to make it the most optimal as possible. It's actually really not very optimal at all. There's a double for loop. And then inside the for loop, there's 2 database queries. There's this .get, which does a query, and then .exists. So the total number of queries is metrics times number of installed metric, or ticks, number of ticks times number of installed metrics times 2. So that's a lot of queries. So this is the ticks table, and it says there's 84 total ticks, and then there's 1, 2, 3, 4, 5, 6, 7, 8, probably about 10 or so metrics times 2. That's a lot of queries. It's taking 3 seconds. So in the next video, I'm going to completely rewrite this function, this make matrix. I'm just going to completely redo it, and then it'll be more optimal. Also, if there's time tomorrow, I'll make another metric. I will make the CPU metric, and it's just it'll be the same way using psutil. There's this one, CPU time, and it just gives you the CPU time for your CPU, and it gives it to you if you have multiple CPUs. And so we'll just do that tomorrow. And also, I'm going to make a few more. There's another one I want to do. It's swap. I'll do that one. Also, some of these are not very useful, but some of them I want to make metrics out of. Yeah, sensors would be useful. Battery is useful. There's boot time, which we already have. But that's it for this video. So now I'll commit. I'm just going to leave this in for now because I'm going to eventually get rid of it. So I might as well just keep it. And I will see you next video.